Is it audible? Hello? Hello? Okay. Good afternoon to all of you. What we have discussed in previous lecture, morning lecture, what we have discussed. Can anybody tell please? What we have discussed in previous lecture? Hello? Anyone? Okay, we have discussed in previous lecture construction of thyristors and how the SCR will be turned on. Okay, silicon control rectifier. So what we have to discuss today? Silicon control rectifier and its characteristics. Okay, silicon control rectifier and its characteristics. We know that the diode allows electric current in one direction. Is it right? Diode will allows electric current in only one direction. Clear? So and blocks electric current in another direction. And blocks current in another direction. In other words, the diode converts AC current into DC current. The diode converts AC current into DC current. This unique behavior of the diodes make it possible to build different types of rectifiers such as off wave, full wave, and bridge rectifier. So these rectifiers converts the alternating current into the direct current. So what we can say here, simply what we can say, the diode is allows the current in only one direction and it will block the current in another direction. So due to this property, okay, due to this property of the diodes, so the diode can be used in the for converting the AC to DC. Okay. Hello, hello, is it audible? Please give the reply. Okay, so due to this, okay, diode will allows the current in only one direction, okay, in this direction only, and it will block the current in reverse direction. Okay, it will block the current in reverse direction. So due to this property, due to this nature of this diode can be used in the for converting the AC to DC. That is in rectifiers. Next point. So these rectifiers may be half wave rectifiers and full wave rectifiers, or bridge rectifier, or center tap rectifier, and so on, etc. Okay. So these rectifier will convert from alternating AC to DC. Clear? So the off wave, full wave, and bridge rectifier uses normal PN junction diodes, two-layer diodes. So if the voltage applied to these diodes is high enough, then the diodes may get destroyed. So the rectifier cannot operate at high voltages. So means what we can say here, in the off wave or full wave or bridge rectifier uses normal PN junction diodes. Okay, normal PN junction diodes means two layer diodes. Okay, so if the voltage applied to these diodes are high, if high voltage is applied to these diodes, then what will happen? The diode may be get destroyed. The diode get may be damaged. It is clear. So why it will may be damaged? Because it will not have the capability to sustain the high voltages. So due to this, if any high voltage is applied to the diodes may be get damaged. So if the diode is damaged, the rectifier will also not work properly. Okay, the rectifiers also will not work properly. So to overcome this drawback, okay, to overcome this drawback, they have developed a special type of rectifier known as silicon controlled rectifier. Special type of rectifier is known as silicon controlled rectifier. This is one type of device, and this device can be used for the high voltage applications, and this device can be used in the rectifiers. Is it clear? So this SCR can withstand the high voltages. Can withstand the high voltages. What it means? Okay. So means even if you are applying the high voltage to the SCR, so it can have the capability, it can handle. Clear? That's why we are going for the silicon control rectifiers. Clear? So because, for example, in HVDC transmission systems, we have to transfer the power for long distances, and we need to transfer this power in DC. So हाई पावर ट्रांसफर करने का है और लॉन्ग डिस्टेंस पे ट्रांसफर करने का है. ओके, सो पावर ट्रांसफर करने के लिए अपन एसी टू डीसी कन्वर्ट करने का. सो एसी टू डीसी कन्वर्ट करने के लिए डेफिनेटली वी नीड टू यूज द रेक्टिफायर्स. So we cannot use the diodes because the transmission lines are operated with the high voltage levels. So for that purpose, we are going for the silicon control rectifier. Clear? Next one. What is the definition of silicon controlled rectifiers? Already we have discussed in morning. Silicon controlled rectifier is a 3-terminal 4-layer semiconductor current control device. Clear? Silicon controlled rectifier is a 3 terminals and 4-layer semiconductor current control device. So you can get the question online examination. Okay, MCQ questions. MCQ question. Silicon control rectifier is dash. Option A, voltage control device. Option B, current control device. Option C, both. Option D, none of the above. Or frequency control device, whatever. So what we can write, silicon control rectifier is a current control device. Clear? Next one. It is mainly used in the devices for the control of high power. Why we are using the say SCRs? One is the converting AC to DC, and second one is the for controlling the power. Clear? So diode we cannot use because diode is not a controlling device. So for controlling the power, we need to use the thyristor. For example, so we need to control the power. So we are having the one load. Okay, we are having the one load, and we are having the supply voltage or supply power. So if you want to control the output, if you want to control the load, so definitely whatever we are giving the input for the load, that will be controlled. Clear? जो लोड के इनपुट क्या देते हैं वो कंट्रोलिंग करना पड़ेगा. So what is the input of the load? Electrical power. So from where we are getting this electrical power? Output of the power electronic converter. Is it right? This is the power electronic converter. Output of the power electronic converter. So यहाँ पे जो power है, okay, this power should be controlled. So in order to control the power, so here the whatever the devices we are using, that should be controlling devices. अगर if यहाँ पर diodes use किया, power controlling होता है क्या? Because diodes are not a controlling devices. Okay, so definitely we have to use the SCRs. So if we are using the silicon control rectifiers, then we can control the power. If this power is controlled, then the load is also controlled. Yeah. So means what we can say here, it is mainly used in the devices for the controlling of high power. Okay. Next one. Okay, it is made up of silicon material which control the high power and converts AC to DC. So this point is also already we have discussed in the morning session. Silicon control rectifier is a unidirectional current controlling device. This is also we have discussed unidirectional like bidirectional, unidirectional device. Okay, so just like a normal PN junction diode, it is also look like a diode. It is also unidirectional device. So diode is also unidirectional, and thyristor or SCR is also unidirectional. It allows electric current in only one direction and blocks electric current in another direction. Okay, normal PN junction diode is made up of two semiconductor layers, namely P-type and N-type. However, the SCR diode, SCR rectifier, means SCR diode rectifier name. This is not a diode. SCR is a made up of four semiconductor layers of alternating P and N-type materials. So P, N, P, N. It is made up of with four different semiconductor materials or with different four layers, P-type material, N-type material, P-type material, and N-type materials. So all these P-type, N-type, P-type, N-type are the differently doping levels. All these four layers are having the different doping levels. In the principle of PN switching was developed by this Tannenbaum or Goldie, Moll and Holland of Bell Laboratories in 1956. Okay, so the silicon control rectifier was developed by a team of power engineers led by Gordon Hall and commercialized by Frank W. So Frank W. Bill Gutzwiller in 1957. In the early days of this device development, it is often referred by names like SCR and control rectifiers. However, nowadays this device is often referred by a thyristor. So means what we can say simply we are calling as a rectifier as SCR, silicon control rectifier. But here generally casually sometimes we are calling as a thyristor, sometimes we are calling as a SCR. So SCR is nothing but thyristor is nothing but a SCR. So don't get confusing because casually we are talking like that. Okay, so whenever we are talking about the thyristor means SCR. SCR means thyristor. Otherwise, we will mention the special name. If it is not SCR or thyristor, so we will mention the name. Okay, silicon control rectifier are used in power control applications such as power delivered to the electric motors, relay controls, or induction heating, and so on, etc. So this is the symbol of the SCR or thyristor. How many terminals are there for thyristor? 3 terminals. What are those? Anode, cathode, and gate. Clear? Next one. So, what are the modes of operation of SCR? What it means? It's a very important question. In how many modes the SCR will be operates? In how many modes the SCR will be operates? Or they can ask the question, explain the modes of operation of SCR. It is for 5 marks question. Very important. Clear? Explain the modes of operation of SCR. So generally the SCR, silicon control rectifier, can operate in 3 modes. What are those? Online students, please. Online students, can you tell the what are the modes of operation of SCR? It is on the screen. It is on the screen. Please tell me. What is this one? Anyone? Anyone? Swapnali Kamble? Swapnali?
Yes, sir.
कौन सा मोड में ऑपरेट होते हैं SCR? What is this one?
Reverse blocking mode.
Yes.
Forward blocking mode.
Yes. What is
Forward
third?
conducting mode.
Forward conducting mode. Okay. So generally, the SCR will be operated in three modes: reverse blocking mode, forward blocking mode, and forward conducting mode. When this SCR is operating reverse blocking mode, when this SCR is operating forward blocking mode, and when this SCR is operating the forward conducting mode. Anyone? Can anyone tell? Current is yes. Current is flowing from okay. So when the current is flowing from cathode to anode, it is operating reverse blocking mode. So okay, well, that is okay, but not exact right answer. Here, what we have written here, off state. Generally, in off state, whether the current is flowing in either direction. Off state means current is zero, where may be forward or reverse. In both cases, current is zero. So there is no chance to flow the current from anode to cathode, cathode to anode. Off state means what? Switch is off. Is it clear? So when the switch is in off condition, that is we have to check. Okay, it is also off state, but we are discussing forward blocking mode. It is on state, that is the forward conducting mode. So we will explain one by one here. First one is the reverse blocking mode. That is also called as the off state. That is also called as the off state. To operate the SCR in reverse blocking mode, so the cathode should be connected to the positive and anode should be connected to the negative. Are you getting this one? Where the cathode is connected? Where it is? कहाँ पे पॉजिटिव है? पॉजिटिव किधर है? This is the positive, na? This is the supply. This may be battery or DC, whatever. Okay, but this is the supply. So this is the positive terminal. This is the negative terminal. Positive terminal of the supply voltage is connected to the negative cathode. Cathode and negative different. Positive terminals of the supply is connected to the cathode. Is it right? Is it right or not? क्या बोलो? But here the condition is what we are discussing: reverse blocking mode. To operate in reverse blocking mode, cathode terminal should be connected to the positive supply, and anode terminal should be connected to the negative terminal of the supply. Clear? Okay. And gate should be open because SCR is having 3 terminals. Is it right? How many terminals for the SCR? 3 terminals. One is the gate, another one the anode, another one the cathode. So gate को कोई supply नहीं देते अपन. We are not giving any supply to the gate terminals in the reverse blocking mode. That's the first condition. And second condition is the cathode terminal should be connected to the positive supply and negative anode terminal connected to the negative supply. So due to this, what will happen? So junction J3 and J1 will become a reverse bias junction. Is it right or not? Morning I told you this one. Okay, if cathode is connected to the positive and anode is connected to the negative, so N type material is made positive with respect to P type material. So the junction J3, this is the J3, na? This is the J3, na? Junction J3. The junction J3 will become a reverse bias. Okay. Next, J1 is J1 क्या forward bias है कि reverse bias है? J1 is also reverse bias because the P type material is connected to the negative, N type material is connected to the positive side. So this is also reverse bias. This is also reverse bias. And the junction J3 is also reverse bias. So if these two junctions are reverse bias, is there any chance to flow the current from positive to negative? Current flowing chances है क्या? There is no chance. But here junction J is the forward bias. How it will become a forward bias? Junction Z is the forward bias. How it will become a forward bias? Yes, with respect to this junction, negative terminal is connected to the negative, sorry, N type material is connected to the negative and P type material is connected to the positive side. Means for forward bias condition, Z2 is the forward bias. This is condition is fulfilled. So, but current flow होने के लिए यहाँ से तो flow होना चाहिए ना. जंक्शन J3 तो फॉरवर्ड बायस होना चाहिए. तो ये फॉरवर्ड बायस होगा, फिर यहाँ से करंट इधर तक आएगा, इधर से इधर तक आएगा, इधर से इधर तक आएगा, तो करंट will flow like this. Is it right? But no current is flowing. Is it right? J3 is reverse bias. There is no chance to flow the current from cathode to anode. That's why in reverse blocking mode, junction J1 and J3 are the reverse bias junctions and junction J2 is the forward bias junction. So due to this, there is no chance to flow the current from cathode to anode. It will act as a open switch. It will act as a open switch. For example, I kept the mobile at this side, so I want to bring this mobile downside. If I left this mobile can come downside. If I will not leave this one, so can it will come to down. So यहाँ पे junction J3 तो open नहीं हो रहा ना. Junction J3 closed है, so it is not releasing any current. So that's why there is no chance to flow the current from cathode to anode. Point is clear? What I am saying? This problem to nahi hai? Okay. So that's why. So during the reverse, during this mode, in reverse blocking mode, the SCR simply will operate as an off state. Simply.
Hello, sir.
Yes.
Leakage current flow होगा ना?
Yes, small leakage current can flow. So that's why I have represented here. I will explain this graph also. Just concepts you have to understand right now. Okay, so and then I will explain the leakage currents, forward leakage current, reverse leakage current. Just get the concept. Again, I will repeat this topic tomorrow. Okay? Is it okay, please? Hello? Who asked the
Yes,
question? Hello. Just I am explaining
Yes,
the
sir.
concept. Just I am explaining the concept, and again this topic I will repeat tomorrow. Okay. So then I will explain one by one. Forward leakage current, reverse leakage current. Is it okay? Because it is very important topic, because we have to conduct the experiment on this topic. First experiment. That's why just first I am telling the concept, and then again I will repeating this lecture. Is it okay? Please. So otherwise I will explain the continuously, no problem. Okay, so in reverse blocking mode, no current is flowing from cathode to anode, but small amount of current is flowing. Small amount of current is flowing. That current can be called as a leakage current. Now is it okay? Small amount of current is flowing. That current can be called as a reverse leakage current. This reverse leakage current can be represented by this one, this magnitude. Okay, so on x-axis we have taken the voltage. Which voltage? Voltage across the anode and cathode. This one. Okay, voltage across the anode and cathode. Clear? So which voltage is applied across the thyristor? Reverse side, the positive voltage. Cathode connected to the positive, negative, anode connected to the negative. So reverse side, the positive. Reverse voltage apply किया ना अपन SCR का तरफ. So that's why this is the plus VAK and this is the minus VAK. VAK means voltage across the anode and cathode, negative voltage. So we have taken the voltage across the anode and cathode on the x-axis, and we have taken the anode current. Anode current means which is flowing through the device. That is called as the anode current. Okay, on the y-axis. So here we have applied the reverse voltage. If this in reverse voltage, no current is flowing. That's why. So we can say simply zero current is flowing. Zero current is flowing. Okay, but small leakage current is flowing. So that leakage current is represented by like this, small magnitude. Yeah, what is this one? Magnitude of the anode current. Clear? So if the voltage is increasing, this voltage is increasing, then what will happen? This reverse voltage is also increasing. This reverse voltage is also increases. Clear? If we are increasing this reverse voltage more and more, then what will happen? At one particular voltage level, the breakdown will be occurs. The breakdown will be occurs. When the breakdown is occurs, then what will happen? It starts to flow the current from cathode to anode. It starts to flow the current from cathode to anode. क्लियर? जब ब्रेकडाउन अकर हो गया तो क्या हो जाएगा? कैथोड से लेकर एनोड तक करंट फ्लो हो जाएगा. So this current will be increases. Okay, when this breakdown is occur and a reverse current is flowing from cathode to anode, so then what will happen? If it will happen, so the thyristor will get damaged. Okay, if it will happen, the thyristor will get damaged. That's why, so the thyristor or SCR should not conduct in reverse direction. If you have applied the more voltage in reverse, if you have applied the reverse voltage more, then what will happen? At one particular voltage level, it will conduct in reverse direction. Okay, so this current will be increases. So, but which current is here? Reverse current. This is the negative current, na IA. Negative, hai na? Okay, so when the breakdown is occurs, reverse current is starts to flow from cathode to anode. So it should not be happen like that. So if it will happen, then definitely the thyristor will get damaged. This point is clear? गेट को ओपन ही रखने का, रिवर्स ब्लॉकिंग मोड में गेट को ओपन ही करने का, because we are not going to turn on the thyristor in the reverse blocking mode. रिवर्स वोल्टेज अप्लाई करके thyristor कभी नहीं करने का. ओके, इफ इन केस रिवर्स वोल्टेज अप्लाई हुआ तो क्या होगा इधर, दैट इज वी हैव टू डिस्कस. क्लियर? नेक्स्ट वन. So if you understand this one, then you can easily understand the next concept. Again, I will repeat. Please don't worry. In practical time. Forward blocking mode. Second mode is the forward blocking mode. Online students, please, what is the second one? Online students, what is the second one? What is the second one? What is the second one? Please, nobody is giving the response. Raut, Anmol.
Forward blocking mode.
Yes. So please answer now. Brushali. 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 So I will put absent. Aishwarya. Aishwarya.
Yes, sir.
What is the second one?
Forward blocking mode.
Forward blocking mode. Yes. Okay. So to operate the SCR in forward blocking mode, what we have to do? Just connections reverse करने का. Same as the previous case, but only positive and negative change करने का. So anyone can explain this one? To operate the thyristor in forward blocking mode, what condition should be satisfied? Which condition should be satisfied? Anode is connected to what? Anode 2 is connected to positive and cathode is connected to what?
Negative.
Negative. Clear? So when the anode is connected to positive and cathode is connected to negative, so then what will happening here? And the gate is open, still open. There is no voltage is applied to the gate circuit. This is the condition. So due to this, the junction J1 will become a forward bias or reverse bias?
Forward.
Forward. Why? Why it is forward bias? That's exactly right answer. Very nice. But why? Please tell me. Because the P-type material is connected to the positive and N-type material is connected to the negative. So obviously this junction become a forward bias. So the current will comes to at this point. Is it right? ये junction open है, so current can freely flow through this junction. यहाँ तक आ गया current, यहाँ तक आ गया. N-type material to P-type material तो flow होना चाहिए ना. But what about the junction J2 is the forward bias or reverse bias?
Reverse bias.
Reverse bias, exactly right answer. Because this N-type material is connected to the positive and P-type material is connected to the negative. So obviously the junction J2 is the reverse bias. So क्या हो गया इधर break हो गया. Current flow होने के लिए बंद हो गया इधर. Clear? So for example, I have taken the one example morning. This is the water tank. Okay, here the one gate is there. This is the second gate is there, and this is the third gate is there. So this पानी flow होना चाहिए यहाँ से यहाँ तक. Is it right? सो पानी फ्लो होने के लिए क्या करना पड़ेगा, इधर तीनों गेट ओपन करना पड़ेगा ना, तीनों गेट ओपन करना है ना। सो एक गेट तो ओपन हो गया है, ओके। सो पानी कहाँ तक आया, सेकंड गेट तक आया, बट सेकंड गेट इज क्लोज। सो वेदर द दिस वाटर इज कमिंग टू द थर्ड गेट, नो, okay. So this gate is closed, so like this same way here also happening, like this same way here also happening. So due to the junction jet is reverse bias, the current is not flowing, the current is not flowing from anode to cathode, okay. But junction J3 is the forward bias here, junction J3 is the forward bias, junction J1 is the forward bias, but junction J2 is the reverse bias, J1 J3, ये J1 है, ये J3 है, बीच में जंक्शन कौन सा है, J2, बट ये दोनों फॉरवर्ड बायस है, J2 रिवर्स है, तो ये ब्लॉक कर रहा है ना करंट को, so it is not allowing the current to flow from the J1 to J3. So due to this, the current is not flowing from anode to cathode, but small amount of leakage current is flowing, okay. So no current is flowing means still it will act as a off switch, still it will act as a off switch. तो करंट फ्लो नहीं हो रहा है मतलब कि ऑफ है ना, clear. So still it will act as a off switch, that's why we have written the off state, that's why we have written here off state. So still in forward blocking mode also the thyristor is operating as a off mode, off state, still it will act as a open switch, still it will act as a open switch, clear. Next one, and current is not flowing but small leakage current is flowing, but small leakage current is flowing. So here voltage across the thyristor, which voltage is applied, positive or reverse, anode is positive and cathode is connected negative, the positive voltage apply किया ना, so positive voltage is applied, this V1 is the positive, so that's why we have done the positive here, clear. So this is the magnitude of the current, but current increase नहीं हो रहा है, so small current flow होता है, this is the magnitude of the current, this is the magnitude of the leakage current. Small current is flowing through the anode to cathode, that current can be called as a leakage current, okay. It is in microamperes or milliamperes, very small, okay. That's why we have represented in the graph like this, is it okay, okay. If we are increasing the voltage, so positive voltage क्या हो जाएगा, increase होता जाएगा, clear. Next, so if you are increasing the more voltage, it will break down block current, break over voltage को, रिवर्स वोल्टेज इंक्रीज किया तो ब्रेक डाउन, अगर फॉरवर्ड वोल्टेज इंक्रीज किया तो क्या हो जाएगा, ब्रेक ओवर, क्लियर. सो आई विल टेल दैट पॉइंट later, that point is also there, that point is also there. So I think you are getting bored, but so you need to understand all of you, so don't get any boring. Are you getting bored online, are you getting bored online students, give the reply. It is interesting or not, इंटरेस्टिंग आ रहा है ना टॉपिक, ओके ओके, थैंक यू. सो नेक्स्ट कंडीशन, ये फर्स्ट मोड हो गया, इट विल ऑपरेट इन द फर्स्ट मोड एंड दिस इज द सेकंड मोड, क्लियर. एंड थर्ड मोड में क्या होगा, व्हाट इज द थर्ड मोड, व्हाट इज द थर्ड मोड, वृषाली,
Forward conducting mode.
forward conducting mode, okay. So to make the on state of this thyristor को on करने के लिए क्या करना चाहिए? So same. So here we have a two steps. Here we have a two methods to turn on the SCR. Okay. Forward conducting mode में लाने के लिए two steps है, two modes है. One is the gate still is open, but anode is connected to positive and cathode is connected to negative. So by increasing this voltage more and more, जितना वोल्टेज है उससे ज्यादा कहीं गुना है. Okay, means for example, if thyristor is required 100 volts, if you apply the 500 or 600 volts, then what will happen? It is the many times than the rated voltage now. Okay, then what will happen? Due to the applied of more voltage, then what will happen? The junction JT is collapsed and it will become a forward junction. So when it will become a forward junction, so then the current is flow through the anode to cathode. This is the one method. Clear? And second method is the by applying the some amount of voltage to the gate circuit. Second step is the by applying the some amount of voltage to the gate circuit. Here in forward conducting mode, the anode still is connected to positive and the cathode is still connected to negative. This is the first condition. Is it okay? And we are applying the some amount of voltage to the gate circuit. Gate circuit को some voltage apply किया इधर. So when the voltage is applied to the gate circuit, then what will happen? The current is flowing through the gate circuit, and it will inject the current into the inner P layer, and it will inject currents into the inner P layer. So what will happening here? A small positive voltage VG is applied to the gate terminal. It is very, very small. Just for example, if the rated voltage of the thyristor is 230, so it requires only 5 to 10 volts for the gate terminal voltage. Small voltage apply किया तो भी turn on हो जाएगा. Okay, so that's what we have told here. What we have discussed, by applying the small positive voltage to the gate terminal. So as we know that in forward blocking mode, current does not flows through the circuit. Okay, in forward blocking mode, current does not flows through the circuit. Current flow होता है क्या forward blocking mode में? Still it will act as a off state. Still it will operate as a open switch. So there is no chance to the flow of the current from anode to cathode. So because of the wide depletion region means the junction jet is the reverse bias. So there is a depletion layer is there. So to flow the current from anode to cathode, this depletion layer should be finished. Okay. So by injecting the current carriers into the inner P layer, then what will happening? Whatever the junction J2 is the reverse bias, here junction J1 is the forward bias and junction J3 is the forward bias already, because I think you got it this point. Positive supply is connected to the P type material, N type material is connected to the negative supply. So junction J1 is the forward bias, junction J3 is also forward bias. So but junction J2 is the reverse bias. So here the depletion layer is formed. This depletion is formed. So while injecting the current carriers into the inner P layer, then what will happen? This depletion layer is going to be finished. So this depletion layer is going to be finished at one particular voltage level of the gate circuit. Then what will happen? This junction J2 is also become a forward bias junction. The junction J2 is also become a forward bias junction. Now the forward bias junction, J1 is the forward bias. Now the J1 is the forward bias. Junction J2 is also forward bias. And junction J3 is also forward bias. So three junctions are forward bias. So three gates are open. So there is no issue to flow the current. So the path will provide to flow the current from anode to cathode. Clear? This is the path will flow the current. This is the positive, so I will indicate the green line. Okay, so when the three junctions are forward bias, then the current will flow from positive terminal of the supply through the anode, through the cathode, and negative terminal of the supply or battery. Clear? So now the current circuit is closed now. Now the device is turned on. So now the device is turned on, that's why the current is flowing. Okay? And one more point here. Once this device is turned on, if you remove the gate circuit, there is no problem. So still the thyristor remains in a turn on condition. But there is a one condition is there that I will tell later in next lecture. Okay? So come remove कर सकते हो. So once it is turned on, okay, so you can remove the gate circuit. But there is a one small condition is there that I will explain later. Clear? So turn on methods of SCR में तो वो point भी बोलूँगा मैं. So now this is the reverse blocking mode. This is the reverse blocking mode, is it right? And this is the forward blocking mode. And forward conducting mode कौन सा इसमें है? Once the thyristor is turned on, so just I will explain you. This is the thyristor. This is the thyristor ना, PN. सिंबल यही है ना thyristor का? Okay, this is the symbol of thyristor na, anode, cathode, and gate. Okay, so once this thyristor is turned on, at this point, when the gate voltage is applied, then the thyristor is turned on. When the thyristor is turned on, then what will happen? The voltage across the anode and cathode. Again, I am repeating, voltage across the anode and cathode only. What about the voltage across the anode and cathode? It will become a zero or something. Switch turn on है तो वोल्टेज क्या होगा इसका क्रॉस. फर्स्ट लेक्चर में बोला मैंने, स्विच टर्न ऑन है तो वोल्टेज क्या होगा उसका क्रॉस, जीरो. So here when the thyristor is turned on, it will act as a closed switch. Once it is a closed switch, the voltage across the switch is zero. That's why this voltage is suddenly false. Clear? So, but we can draw the zero, but small voltage drop is present. That is maybe 1 volt or 2 volts. That's why this small voltage drop is present. So this is the magnitude of the voltage. Once the thyristor is turned on, what about the current? Current is flowing and it will be increases. So that's why the current is increases. Is it right? Voltage decrease हुआ उसका क्रॉस, current increase होगा. This is the forward conducting mode. This is the forward conducting mode. Any doubt, please? When the device is non-conditioned, voltage drop across this SL is zero, but small voltage drop is present. That may be 1 volt or 2 volts. That's why this small voltage drop is represented here, and the current is increases. Current increase होगा ना इसका through. It will act as a closed switch. Current flow होता है. So the current is increases. This is the forward conducting mode. Yes.
बोलून काय भांडण व्हायचं बोलते.
Yes. Any doubt, please? Any doubt? Somebody saying. Somebody is saying, please, any doubt? Okay. What is your doubt? ये वाला क्या? This is the anode current. Current which is the current which is flowing from anode to cathode. So here you can see this diagram. So it's a nice question. This current is increasing, na? So once the device is turned on, the current is start to flow from positive terminal of the supply anode to the negative. So कौन सा current ये? Anode current बोलते हैं उसका. Okay, simply device के through current flow होता है जो main सब current है. So उसको अपन simply we are calling as a anode current. So we are not representing any gate current here. Clear? So if you want to draw, you can draw separately. Separate, you can take the graph and you can draw the graph. Somebody is saying, please tell me what is the problem? Kajal, Solanki. Kajal Solanki. Okay, so gate current is used only for turning on the device. Damage the हाँ डिप्लेशन जो लेयर रहता है उसको फिनिश करने के लिए. सो वो डिप्लेशन लेयर फिनिश करने के लिए टू मेथड्स है. आपको ये वोल्टेज भी इंक्रीज कर सकते हो बट ज्यादा वोल्टेज अप्लाई करना पड़ेगा. आपके पास अगर 230 वोल्ट से अगर आपको गेट सर्किट यूज नहीं करना है तो वही सप्लाई से अगर टर्न ऑन करना डिवाइस को तो आपको ज्यादा वोल्टेज लगेगा. तो कहाँ से लाओगे कितना वोल्टेज? इसलिए अपन को गेट सर्किट को स्मॉल वोल्टेज पे अप्लाई किया डिवाइस इजीली टर्न ऑन. That is the easiest method to turn on the SCR and it is the safest method and the efficient method. Clear? Okay. So these are the this is the operating modes of the SCR and this is the reason VI characteristics of SCR. This is the, so very important question. Explain the VI characteristics of SCR. Okay, draw and explain the VI characteristics of here. VI means voltage and current. Okay, voltage across the anode and cathode and anode current. This is the, so if he will ask the question, explain the VI characteristics of SCR. So you have to write all these three modes: reverse blocking mode, forward blocking mode, and forward conducting mode. And step by step you have to explain with needs diagrams like this. What I have explained like this. जैसे एक्सप्लेन किया ना डायग्राम्स लेकर ऐसे स्टेप बाय स्टेप आपको डायग्राम्स ड्रा करके एक्सप्लेन करना पड़ेगा. नेक्स्ट फाइनली यू शुड ड्रा दिस ग्राफ. ये की ग्राफ ड्रा किया चलता है. ये मैंने आपका अंडरस्टैंडिंग पर्पस के लिए मैंने ऐसे ड्रा किए तीन. फर्स्ट ये वर सॉरी फर्स्ट दिस वन एंड सेकंड थोड़ा सा एक्सटेंड हुआ. थर्ड क्या हुआ और एक्सटेंड हुआ. This is the first one and I have an extended second and third. So only you can draw the one graph. No need to all. But circuit diagrams सभी draw करना है और explain भी करना है. Reverse blocking mode के in reverse blocking mode what will be the condition? Cathode is connected to what? Anode is connected to what? Gate should be what? Open or switch. And what about the junction J1 and J3? Clear? What about the junction J2? So all these things we have to write. Okay. So I will explain these terms. What is reverse blocking mode? What is the forward blocking mode? What is the forward breakover voltage? What is the forward leakage current? Okay, anode current. I will explain again here. So these are the very important definitions. What is leakage current? What is reverse leakage current? What is forward leakage current? What is breakdown voltage? What is breakover voltage? Clear? And what is latching current and what is holding current? All these things. So number of questions can arise in practical examination. So external examiner will ask the question, number of question on this concept. Yeah. So I will give the definition for all these things. But nobody is writing the notes. So how? Nobody is writing the notes in classroom. Just wait. Online students, are you writing the notes as per the triple P pattern? Online students, please give the reply.
No.
Why? Why, please tell me. 11 to 13, 18, 19,